Welcome to Topics in Digital Economics. My name is Paul Belflam.
The topic of today is platform pricing strategy. In this presentation, I'm going to use a very simple example, but in spite of its simplicity, you will see that we can draw from this example very important lessons that show how platforms must choose their prices in the presence of network effects. So let's go to the example. There is just one platform, and you can think of it as a marketplace that intermediates trade between buyers and sellers. There are 6 buyers and 6 sellers who may join the platform, and we assume that once they're on the platform, they transact with one another. So each buyer buys 1 unit from each seller, and doing so, buyers and sellers extract some surplus from each buyer-seller transaction. Now, we simplify the buyer side by assuming that all buyers are the same, in the sense that they all derive the same surplus from each transaction, and this surplus is equal to 6. Now, sellers are different. Seller I being any value between 1 and 6, seller I derives a value I minus 3 per transaction. That will become clearer on the next slide. Now, the platform sets transaction fees. So per transaction, each buyer and each seller has to pay a fee to the platform. We call this fee AB for the buyers and AS for the sellers. Okay, so that allows us to compute the surpluses for buyers and sellers for a given number of buyers and sellers that are present on the platform. We call the number of buyers on the platform by small case nb, and small case ns denotes the number of sellers on the platform. So it can be any value between 0 and 6. Okay, so as I said before, all the buyers are the same. They've got the same surplus function. Just to make sure we understand it well, there will be ns transaction for each buyer, because the buyer is going to meet ns sellers. For each transaction, the buyer earns 6, but has to pay AB to the platform. Okay, and we've got the same form for the surpluses of the sellers. The difference here is that the sellers are different. So if I take seller 6, for example, remember, seller I is willing to, is earning I minus 3 per transaction. So 6 minus 3 makes 3. How many transactions is seller going to make on the platform? Well, he or she is going to meet NB buyers. So you multiply NB by 3 minus AS, which is the transaction fee that the seller has to pay to the platform. Okay, so the question now is, which transaction fees should the platform set? Okay, and we are going to look at 2 types of platforms. We're going to start with a for-profit platform, whose objective is to maximize the profit it makes. And then we are going to look at a non-for-profit platform, whose objective is to maximize the value that is created for buyers and sellers. Okay, so let's start with a for-profit platform. How do we write the profit of the platform? Well, you can think of the sum of the profit made on the sellers and the profit made on the buyers. And so the profit made on the sellers is the transaction fee for sellers times the number of transactions that are going to take place. And the number of transactions is the product of the number of sellers by the number of buyers. And same thing on the buyer side. The only difference here is that what is collected is the transaction fee on the buyers. Okay, so that's what the platform is maximizing. Now, this is called here the myopic way, because I want first to show what the platform should not do. Okay, and the temptation would be to think of the 2 sides as completely separate, and first try to find what is the profit maximizing fee on the buyer side, just caring about profits made on buyers, and then do the same on the seller side. Okay, so let's do that, and then we'll show why this is not the good way, the right way to think about the profit maximizing prices. Okay, well, in this example, things are very simple on the buyer side. They are all the same. They're willing to pay, they earn 6 per transaction, so this is what they're willing to pay. And as long as the price is not above 6, all buyers are willing to participate and join the platform. Okay, so here the demand for participation of the buyers is totally inelastic. Okay, and so this puts the platform in a very strong position, and it can extract all the surplus from the buyers by setting a price equal to their willingness to pay. Okay, so AB is going to be equal to 6, and all buyers, the 6 buyers, are going to participate. Okay, now let's move to the seller side. Here things are a bit more complex because the sellers are willing to pay different prices to be on the platform. Okay, so actually, if you just focus on the seller side, the prices the platform may set are going from 3 to -2. Okay, and as you lower the price, you increase participation. Okay, so here with a price of 3, only seller 6 is willing to participate. If you decrease the price to 2, seller 5 is participating as well, then seller 4, and so on and so forth. Okay, well, we already know that 6 buyers are going to participate, so you can compute in the last column here the profit that the platform is going to make on the seller side. Okay, so I repeat, this is AS, the amount that sellers have to pay per transaction, times the number of transactions, which is the product of NS and NP. Okay, so if you do these computations, and you can check later at your own rhythm if you want, you see that you maximize profit on the seller side if you just attract 2 sellers by having a transaction fee AS, which is equal to 2. Okay, so putting things together now, we see that AS should be equal to 2, NS is equal to 2. Remember that AB is equal to 6 and NB is equal to 6. And so the total profit for the platform is 6 plus 2, AS plus AB, times the number of transactions, 12, that makes 96. Okay, now we call this the myopic way. So you expect that it's possible to do better than that, and you may already have figured out that prices here are not optimal. So what is missing in this myopic way? Well, what the platform misses is that it doesn't realize is that by changing the fee on one side, it affects revenues on the other side. And sorry for the typo here. And especially by lowering the fee on the seller side, it's possible to attract more sellers and so to generate more revenues on the buyer side, because buyers will make more transactions and they will pay fee on more transaction, and this is something that the platform can obtain as profit. Okay, so let's redo the analysis now by looking at the big picture, the total profit, not just the profit on the seller side, but also the profit on the buyer side. As I just said, changing prices here on the seller side affects the profit that the platform makes on the buyer side. Okay, and so we were here from the last slide. We stopped at AS is equal to 2, and only 2 sellers are attracted to the platform. Now, let's see what happens if we lower the price. Well, if we lower the price to 1, then an extra seller is joining. Okay, it reduces the profits on the seller side, but it increases the profit on the buyer side more than proportionately. Okay, so the total profit increases by 30 if you do that. Okay, so that already illustrates the idea that you may want to lower your profit on one side so as to increase it on the other side. And if you can increase more than you've reduced, you increase the total profit. Okay, can we do even better than that? Well, if you reduce the price to 0 on the seller side, well, you reduce even more the profit on the seller side, but you still increase more than proportionately the profit on the buyer side, which again improves the total profit. Let's do it one more round. Well, you see that if you start subsidizing sellers by having a negative price, you further decrease the profit on the seller side, but you still increase the profit on the buyer side in a higher proportion, meaning that you increase total profit. Okay, and let's just check that it's not possible to do better than that. At some point, if you further decrease the seller fee, you would decrease profit on the seller side more than you increase it on the buyer side, meaning that you would reduce your total profit. Okay, so here the profit maximizing structure of fees, combination of fees, and you need to think in terms of fee structure, the profit maximizing one is such that AS should be equal to -1, which leads to 5 sellers joining the platform and a total profit of 150. Okay, so let's take stock of what we've learned so far. First, we've learned that prices must be jointly optimized. Why? Because when you change price on side 1, you will change participation on side 1, which, because of cross-side network effects, will change participation on side 2. And if participation changes on side 2, you also change the profits on side 2. Okay, so there is a link from the prices on side 1, from the price on side 1 to the profit on side 2, which was totally ignored in the first approach, the myopic approach. Okay, now because of that, we've illustrated that it may be profit maximizing to subsidize participation on one side. Okay, why? Because you will make losses on that side, but if you can recoup these losses by higher profits on the other side, overall the total profit will increase. Okay, now if you compare buyers and sellers in our example, remember buyers have a totally inelastic demand, whereas the demand for sellers is elastic, and it's not a surprise that you will have the lower prices on the seller side, which is here, I repeat, the side that is more sensitive to price changes. Okay, so 3 very important lessons that can be generalized to richer models of platform pricing. Okay, so let's consider now a not-for-profit platform. Okay, well, the objective is different. It doesn't want to make profits. Of course, it cannot make losses, so there is this constraint that profits cannot be negative. Okay, remember here, I didn't say it, but we assume away all costs for the platform. Okay, but it doesn't mean that the platform can make losses. It just needs to have non-negative profits. Okay, in this specific case, it means that the total transaction fee must be at least as large as 0. Okay, so profits are a constraint here. They cannot be negative, but the objective is to maximize the value created for the users. Okay, now if you think, sorry, I'll come to that. But first of all, what does it mean? What are the values for the buyers and for the sellers? I want to have an aggregate measure here. So remember, for the buyers, it's rather simple. They're all the same. So it's 6 times. So sorry, for any price which is below 6, which will make sure that they all participate. And for a given number of sellers on the platform, the total value created for buyers is 6 times 6 minus AB times NS. Okay. Now for the sellers, well, it depends. I mean, the higher the price, the lower the participation. So let's take the first line here. For any price between 2 and 3, only seller 6 participates and makes a surplus. Okay. Then if you lower the price below 2, you also have seller 5 that is participating. So if you add up their surpluses, this is what you get: 5 minus 2 times AS times NB, and so on and so forth. Okay, so you can check these computations yourself if you want. Okay, now this is what I needed to be able to say something about prices that must be chosen to maximize the total value created for the users, and this total value for a given number NS and NB is going to be the sum of VB and VS. Okay, so the first thing which may come to mind is that, well, it's a non-profit platform, so it should be free. I mean, I shouldn't set a price, a positive price for buyers and for sellers. Let's make the access to the platform completely free. Well, what I will show here is that this is mistaken. Okay, that's not the right approach. This is not how you will maximize value for your participants. Okay, so let's just prove it here. So if it's free of charge, AS and AB are equal to 0, you're going to have, well, the 6 sellers, buyers, sorry, that's for sure, but only 4 sellers. Okay, and if you compute the value which is created using the formula I showed on the previous slide, well, this is what you obtain. 144 for the buyers, 36 for the sellers. Of course, there is no profit. And if you add up the whole thing, so W is my measure of welfare, if you want, and I've put the 2 prices here, 0 and 0, and this is what you obtain, 180. Okay, let me show you can do better than that. Well, and it's the same logic as before. You have an interest here in subsidizing sellers. Okay, well, you're going to pay them one per transaction to come. Okay, of course, you're bound by this non-negative profit constraint. So it means that if you lower the price for sellers, you've got to increase it in the same proportion for buyers. Okay, so the sum is still equal to 0. Okay, well, it doesn't change anything for the buyers. I mean, this very simple example here, they all participate as soon as the price for them is below 6. Okay, but the advantage of subsidizing sellers is that you have one more seller joining, which creates more transactions and thereby creates more value for everyone. Okay, and so if you do the math, which I've done here for you, you see that there is an improvement of 6 for the value for the buyers. The value of the sellers increases by 24, profit is still equal to 0, and so the new total value is 210, which is 30 above the 180 that you had before. Okay, so clearly here, a different strategy, which is not free for all, but subsidies on one side and a positive price on the other side. This alternative strategy does better, increases the value for everyone, and this is important to note, even though buyers pay more, they get a higher value from participating on the platform. They would be happy to pay more. Okay, so don't fall in the fallacy of free for all. Even if you have a non-for-profit platform, it doesn't mean that it has to be free for the same reasons as before. So what else have we learned? Well, I repeat, making a platform free for all users may not be the best way to maximize the value it creates. Why? Because you want to increase network effects, and you can do so by subsidizing one group. And of course, because you've got this constraint of not making losses, you will need to increase the price on the other side. But as I just said, this is to create more value. And so the participants are going to be happy to pay more if it creates more value on the platform. Okay. Now, another message that can be drawn from this analysis, and which is true for any type of platform, it is the structure of prices that matters. It's not just the sum AS plus AB. It's how this sum is split between what is paid by the buyers and what is paid by the sellers. And here we've got a fundamental difference between platforms and pipelines, because on a pipeline, think of a firm which is buying goods and reselling them to consumers. Well, there, I mean, how this AB and AS is split doesn't make a difference. There is a neutrality here in the way this is split, and that should remind you of your first economics classes, where it is said that in a perfectly competitive market, whether a tax is paid by the buyers or by the sellers doesn't make a difference. Okay, so I repeat, in a normal market, if you want, the split between what is paid by buyers and what is paid by sellers in general doesn't make a difference, but on a platform it does, because it influences the participation, and the participation is synonymous of value because of the network effects. Right, so let's try to generalize a little bit the messages we've got here. In general, if you consider a monopoly platform, but that also applies by and large to platforms competing with one another. Okay, so the big message is the following. You've been taught how to find the profit maximizing price of a platform, of a monopoly, by looking at the first order condition for profit maximization, which can be reinterpreted in what is called the monopoly pricing formula. Okay, which on the left hand side you've got the margin, the price minus the cost divided by the price, and on the other side you've got the inverse of the elasticity of demand. Okay, so in words, you remember that the capacity for a monopoly to increase price above marginal cost is inversely related to the elasticity of demand. Okay, why? If the demand is more elastic, if consumers are more sensitive to prices, well, it's harder for the monopoly to increase the price above the marginal cost. Okay, now here we've got a monopoly platform, so it still has this idea of linking prices to the elasticity of demand. Okay, but this formula for profit maximization must be adapted. Why? Because in the presence of two sides which are related to one another, it's actually very difficult to attribute both the costs and the revenues to one side or to the other. Okay? Revenues are co-generated by the two sides. Okay? And in particular, if you think of the costs of attracting one more, let's say, seller, okay, well, in this example here, the cost was equal to 0, but in general, you may think of the platform having to pay something to, for example, in terms of advertising, to attract one more seller. But this is not the true cost that the platform needs to take into account. We know that economic agents, they think in terms of opportunity costs. Okay? And the opportunity cost is lower than the marginal cost. Why? Because if I am the platform and I attract an extra seller, I know that it will allow me to raise revenues on the buyer side. Okay, so the true cost of attracting a seller must incorporate this extra revenue I make on the other side. Okay, so imagine that I had to pay 10 in advertising to attract this extra seller, and I can earn 3 in extra revenues on the buyer side. Well, the true cost of attracting this extra seller is 10 minus 3 is 7 and not 10. Okay, so this is very important. The idea of adapting prices to the price elasticity of demand is still there, but you need to reevaluate this rule by looking at the right costs, the opportunity cost, which, because of cross-group network effects, these opportunity costs are lower than the marginal costs you can derive from your cost structure. Okay, now if you compare the prices you need to set on the two sides, here is a general rule. You're going to set a lower price, so have a lower margin, potentially negative, on the side where either the price elasticity of participation is higher, and this is what you would have in any market, and this is new, you're going to set the lower margin on the side where the cross-group network effect generated on the other side is larger. Okay, so what does that mean? It means that you want to lower the price more on a group, for a group that exerts a large attraction power on the other group. Okay, so remember my example about the cost being 10 minus the revenue 3 that you generate on the other side. Okay, well, if you generate a larger revenue, for example 4 instead of 3, well, the true cost is going to be 6 and not 7, and that drives you to lower the price even more. Okay, so this is the reason why you want to lower the price more on the side that has a large attraction power on the other one. Okay, I think that's it for today.